Good morning. Welcome to this video. We are going today to be talking about right triangle trigonometry, which really boils down to three functions that we use that help us do trigonometry with any angles in a right triangle. Now we still have to have right triangles for now. Eventually we'll kind of let that go and we'll talk about any triangles, but for now we're just letting the angle measures go and we can talk about any angles. So the three functions that we're going to be talking about today are what we call sine, cosine, and tangent. They're what's listed at the top of this table here. And they all come with abbreviations. These are the abbreviations that your calculator uses. And if you look at your calculator, you might see some buttons that you can probably guess are these three functions. So let's go ahead and start. Sine is represented with an S-I-N. Okay. We still say sine. I know it looks like sin, but we still say sine. Same thing for cosine. It's three letters. It's C-O-S. Okay, a lot of people try and say it's cos. It's not cos. We still say cosine. And we got to make sure we know what we should be saying there. And then our abbreviation for tangent looks like tan, T-A-N. Okay, and again, we say tangent. We don't just say tan. Okay, so even though we have these abbreviations, we still say the full word. We just use these abbreviations when we're doing our work, just so we don't have the full words in there. It makes it a little easier to work with. And this is what your calculator uses too. So we need to make sure we know those. Okay. As far as the symbols, we actually have a little bit of a phrase that we use when we're working with our trigonometry. I'm going to move up to the top of the page here and write this. So that phrase is what we know as SOHCAHTOA. So I'm going to write this out here so you can see it all the way out. So it's 9 letters here. We have S-O-H, C-A-H, and T-O-A. So this actually is all of the right triangle trigonometry stuff into one word. Okay, it's SOHCAHTOA. And you can see even here I kind of split it into 3 chunks. Those are the 3 chunks for each of our functions. So S-O-H, that goes with sine, C-A-H goes with cosine, and T-O-A goes over here with tangent. Okay, so the S, the C, and the T, those are our functions here. They're the sine, the cosine, and the tangent. Okay, then we have an O, an H, and an A, and an H, and an O, and an A. So we got to figure out what this O, A, and H stuff are. So over here on the side, I'm just going to write this out. O here stands for opposite, okay, which is talking about the opposite side from the angle. So if I have a triangle, I'm going across the shape, actually going to the other half. Adjacent is what the A is. This is adjacent. Okay, and adjacent stands for kind of the side that's next to the angle. And we'll talk about how we know which one, because we really need 2 angles, or 2 sides to make an angle. And then H here, this is for hypotenuse. Hypotenuse. Okay, so hypotenuse is for H. So this is actually telling us how to do these. Now, all of this stuff here is really talking about what we call the trig ratios. And a ratio is really just another word for a fraction. So if I have SOH, this is really for a fraction. This is S and then O over H. C and then A over H and T and O over A. Okay, we're actually doing some division there. And that's what we're going to start to put into words down here once we get there. But for the symbols, this is the SOHCAHTOA line. So we're going to go ahead and fill those in. So I'm going to go ahead and try and stay consistent with my colors here. So we have SO, then we have KA, and then we have TOA. Okay, so we got SOHCAHTOA. Okay, now let's talk about it in words. So when we are working with these, we are going to be setting up this fraction. So we're going to start with our trig ratio. So here I'm going to start with sine. And we're going to say that that is equal to O over H. Now, if you notice here, I left a little blank. We're going to talk about that in just a second. But I have the S is equal to O over H, which is really what I put up here at the very top, O over H. Okay. Now, O and H actually stand for things. This is opposite over hypotenuse. Okay, if you want to abbreviate those and you know what those mean, that's fine. Okay, but we got opposite over hypotenuse. Okay. Now, I've left this blank here. When we take the sine, we actually have to indicate what angle we're taking the sine of. So we're going to put some sort of angle in here. Now, we have a symbol that we use when we don't know the angle. That angle is what we call theta. So I'm going to put a theta in there. Okay, and we used that earlier in the year. Hopefully you still remember that. And sometimes we'll put letters in there if we're talking about an angle A or B or C or something like that. But theta is just kind of our general, kind of like X. We just use it for everything, but we use it for angles. Okay? And we can do the same thing here for the cosine column, except now instead of sine, I have cosine, and I'm going to have that of theta. and that is going to equal, I have A and H. So A again is adjacent, and then H is still the hypotenuse. Okay, so we have adjacent and we have hypotenuse. Okay. And then the last one, we got tangent. So tangent of theta is going to equal the opposite over the adjacent. Okay, we got opposite and we got adjacent. Okay, and that's really, if you know this line, you will know basically how to do everything in this section. Okay, but this line itself is kind of the really important one. Okay, now let's talk about the actual pictures here. So for all of these, we do still have to be working with right triangles. However, we do not have to have our special right triangles. So I'm not limited it to just a 30, 60, 90 triangle or just an isosceles right triangle. We can now talk about some of the other triangles as well. Okay, and so to do this now, I'm going to look at each of these triangles. I have to pick an angle to work with first. So for sine here, I'm going to pick this angle down here at the bottom. Okay, if I look at opposite, opposite means I'm going directly across my triangle. So if I go directly across from this angle here at theta, that means I'm over here on this side. I'm going to call this side my O. Okay, and then my hypotenuse is still the side across from the 90. That's not going to change. Okay, now questions do come up sometimes of, well, what if we switch to the other angle? Does it change this? And it actually does. I'm going to draw this in. I prefer that you didn't, just because in your notes it's going to get a little bit cluttered. So I'm going to switch to pink here. Now that pink is not good to see. Let me try a different color. Let's go to purple. Okay, so for purple, okay, there's our theta. Now if I do opposite, I'm going down here. This side along the bottom is now my opposite, but the hypotenuse here is still the same. So that one's going to stay. So if I look at that ratio and start dividing numbers here, I'm going to be dividing different things. But that's fine because I've switched to different angles. The angles are changing as well. So something is changing on both sides of the equal sign, so they're going to still stay equal. Okay? And we can move over to the cosine chunk of things as well here. If I switch to cosine, I'm going to still work with this bottom angle here, theta. If I look adjacent, is now the side directly next to that angle. Okay? Now, here it's the side on the bottom. I know it's not the other side here because this one already has a name. That's the hypotenuse. Hypotenuse kind of trumps out everything else. Okay, if that's the hypotenuse, it's the hypotenuse. We can't change that. Okay, but this side is then the adjacent because it's forming this angle. It's adjacent to the angle. It's actually touching it. Okay, which means then I could find the cosine of that using A and H. Okay, if we look at tangent, we have opposite and adjacent. Again, if I look at this angle down here, opposite and adjacent are going to be those two sides. Okay, and if you'll notice, I have O and A here from the other pictures as well. Those aren't changing because I kept my angle the same. Okay, but I don't need to worry about the hypotenuse on tangent. Okay, I just don't need it for this one. Okay, so with all of these, the nice thing is I really have three pieces that I need to know. I need to know an angle measure, and I need to know two sides. Okay, and that works for all three of these different functions. And because of that, we can actually find one of those missing pieces if we're missing one. If I know two of the three, I can always find the third. And so today specifically, we're just going to be talking about how to find missing sides. Tomorrow, we'll get into more of the how do we find missing angles. We actually have to use a similar version to these trig functions, but we actually have to be a little bit careful with the way we do that. So we're going to save those for tomorrow. But today, we're going to work with just the angles. So we're going to be skipping some of the problems through your notes here, but we can at least get started with them. Okay? So for number one here, we got the tangent of 26. Now this is where your calculator can come in. This tangent of 26, it's just a number, and your calculator knows it. We just have to tell it to find it. So there are a couple different things in your calculator that can change this to give you wrong answers. So before we do anything, we got to make sure our calculator is ready for this. So I'm going to go ahead and slip a calculator in here. Hopefully you can see that. So we have a way to check to make sure our calculator is set up right. That check is to do the sine of 90. When we do the sine of 90, this needs to be 1. If it's not 1, our calculator is not set up right. It's not in the right mode. So if I do sine of 90, I did not get 1. So my calculator is not set up correctly. I did this on purpose so that we could see this. So in order to get it correct, if you look up here next to the second button, there's a button that says mode. I'm going to click that, and it brings us into all of these settings. The one that we need to look at is this third line where it says radians and degrees. So I need to change that radian over to degree. Okay, and that's what we're going to do there. Once I see that switch, I can cancel out of that, just do second quit. And now if I do sine of 90, it gives me a different answer. It gives me 1. Okay, eventually we'll talk about what those radian things are. We're just not quite ready to be there yet. Okay, so we're going to stick to just degrees for now. So back on my calculator here, if I want to find tangent of 26, I can just type tangent of 26 and hit enter. And I get this really nasty decimal looking thing here, and that's really what all these trig functions are. Is they're these nasty decimals that kind of go on. They don't really have patterns to them. Very rarely do we get a nice even decimal here. Okay, and for this sake, it did not tell me how to round, but with trig functions, we usually want to go at least 3 places, sometimes even 4 or 5. For this one, I'll go ahead and go to 3 places. So tangent of 26 is going to be 0.488. If I round the 7, rounds the other 7 up to an 8. So we have 0.488. That's going to be our tangent value here. Okay. Next up, we're going to actually skip part B for now. Don't completely cross it out. We're going to come back to that one tomorrow. But for today, we're going to cancel or skip that one. Okay. Now let's look at number 2. So number 2 is asking us to find the height of this tree. And we have at a location 50 meters from the base of the tree. The angle of elevation to the treetop is 30 degrees. We want to find the height to the nearest meter. So I'm trying to find this side here. Okay? And if I look, there's a vocab word here that we need to talk about. We got angle of elevation. Okay? Angle of elevation actually has a partner word that goes with it. It's called angle of depression. Okay, which they kind of go together. So angle of elevation means we're starting with a horizontal and we're going up. That means I'm talking this angle here. Okay, angle of depression means I have a horizontal and then I'm turning down. That means I have an angle here. So it's just kind of telling us where the location of that angle is. We'll see this a lot in our story problems. We just got to recognize where that angle measure actually needs to go. Okay, but for this one, they actually gave us a picture here too, so we didn't necessarily need to know that. We're just good to go with this picture. Okay, and if I look, I'm given 2 pieces of information. I have an angle measure, I have a side, and I'm trying to find another side. So this to me is starting to scream kind of using one of these trig ratios because I have 2 of my 3 pieces that I need. So the first thing I need to decide is what kind of trig ratio do I need. So I know I'm working with this angle. This is the angle I'm working with. So I got to figure out what are these other 2 sides. Well, if I'm at this angle, the 50 here, this is an adjacent side. Okay, and the x here, that's across from it, so this is going to be an opposite side. So if I switch back up to my table here, I know I'm using O and A, which is TOA, that's part of tangent. So I want to use the tangent function here, and I'm going to try and set up this fraction here, kind of this part in words. So I'm going to do tangent of the angle is equal to the opposite side divided by the adjacent. So if I do that down here, I'm going to start with the tangent of the angle, which here is 33. So I have tangent of 33 degrees is equal to the opposite, which I don't know, that's just x for now, divided by the adjacent, which is 50. Okay? Now at this point you could type in the tangent of 30 into your calculator, but you're going to get a decimal, and we don't want to round these things. We want to keep them as exact as possible for as long as we can. So instead of doing that, I'm just going to start to solve this, which means I need to multiply by the 50 on both sides. That's going to cancel on the right side, multiply by 50. Then I need to find the rest. So I'm going to have right now x is going to equal 50 times the tangent of 33, which is my answer, but I really want to know what that's equal to. So in my calculator, I'm going to go ahead and type that in. So over here, I'm going to do 50 times the tangent of 33. Okay, actually here, we'll do 50 times the tangent of 33. So get that all in there, make sure you close your parenthesis, and hit enter. And now this one is actually asking me to round to the nearest meter. So if I round to the nearest meter, the 4 tells me to stay there. So my answer here is going to be 32 meters. Okay, and that's going to be the height of the tree. And that should make sense to us. If we're 50 meters away, that's pretty far. That angle's pretty shallow. I'm not looking up too far, which makes sense. So we're going to go ahead and stick with that. Alright, on the back here, we are going to actually skip number 3. And we're going to come back to that one tomorrow. So we'll ignore that one for now. But let's look at number 4 here. So for number 4, we are asked to find the exact value of the tangent of 60. So as soon as we start to say exact value, that means I cannot round. Okay? I need to have exact answers. I can't round. I can't take square roots. I have to make sure everything's just a perfect number for me. Okay? Now, in this case, because I'm asking for a tangent of 60, 60 is one of those angles that we've already talked about. We can talk about our 30, 60, 90 triangle, which I already have here. Okay? If I'm asking for exact values, more than likely the triangle that we're working with is one of our special triangles. So here's the 30, 60, 90. It might be our isosceles right triangle, but somewhere you're going to see one of those triangles that we should recognize. Okay? So if I'm doing tangent of 60, 60 right now is on this top side. If I'm looking for tangent, I need the opposite, which is going to be the x squared of 3, and the adjacent side, which in this case is just the x. Okay, and I know I need to divide those, so I'm going to go ahead and do that. I'm going to take the x times the square root of 3 and divide it by x. Okay, now that's a relatively nasty fraction to work with. We don't like variables on top and bottom, so we're going to see if something cancels. Well, if I'm multiplying on the top and dividing by an x, these things actually cancel right away for me. The x's cancel out. So all I'm left with is the square root of 3. So what that tells me is that our exact value of tangent of 60 is the square root of 3. And I can actually check that. So on my calculator, if I do tangent of 60, we have 1.732, and it kind of keeps going. And then I can also check the square root of 3. If I do square root of 3, oops, I get the exact same thing. So those two are definitely equal to each other. And there's our first kind of exact value that we're going to work with. We're going to do a lot more with these exact values. We're not going to do too much with it today, but once we get to unit circle, we use these things quite a bit. Alright, let's move on to number 5 here. So number 5 is working with this triangle over here on the right side. Okay, we got our 5, 12, and 13 kind of as our side links. And I am asking you to find a bunch of different values here. So I'm asking for sine of A, cosine of A, sine of B, and cosine of B. So if we start looking here, if I want to find sine of A, this is my angle I'm working with. Sine, I need to use opposite and hypotenuse. So if I label the 5 here is going to be my opposite because I'm going across. 13 is going to be my hypotenuse because it's across from our 90. Okay, so if I do sine, that's going to be O over H, or in this case, 5 over 13. Okay. For part B here, we're going to find cosine of A. So I'm still working with the same angle, but now I need the adjacent side. So I'm going to come down here, which is going to be the 12. And now if I do that, I'm going to have 12 over 13 for my adjacent side. Okay. Next we have sine of B. So now I'm switching to this other angle up at B. I'm going to switch colors too, so it's a little easier to see. If I do opposite of B, now I'm at the 12. So I'm going to label that with a red O here. That's going to give us 12 over the hypotenuse, which is across in the 90. That's still the 13. So our hypotenuse again doesn't change. That's going to be our 13 there. Okay, part D is the cosine of B. Okay, cosine of B is again going to be the adjacent side, which here is going to be the 5 over the 13. Okay, now hopefully you can start to see some patterns here. We actually have a little bit of some numbers that are showing up a couple times here. So we got cosine of A and sine of B are actually the same, and then sine of A and cosine of B are also the same. We got to have these pairs going on. Which if we think about what we're doing, when I go from sine of A to cosine of B, I'm talking about the 5 and the 13. I'm going opposite of A and then to the hypotenuse. If we do cosine of B, I'm going the adjacent, which is the 5, and then to the hypotenuse. I'm using the same part of the triangle, but because I switched to a different angle, the trig function I'm using also had to switch. Okay? Same thing with cosine of A and sine of B. Okay? I still have that same relationship. However, if you look here, I didn't do anything with tangents. Okay? Tangents do not follow this. If I do tangent of A and tangent of B, I don't get the same thing. They're related, but they're not the same. We'll talk about that a little more another day. Okay? We're going to do one more problem here. We're going to do number 6. We'll save number 7 for tomorrow in class as well. Okay? So last one here, I have an angle of 35 degrees. I'm going to call that my theta. That's my angle I'm working with. I got a 25 and an x. So I need to figure out what sides these are. 25 over here is going to be across from theta. So that's going to be our opposite side. X is across from the 90. That's our hypotenuse. So I'm using O and H. That means I'm talking about SO, which is SOH. So I have sine. So I'm going to do sine of my angle is 35 is equal to 25 over x. Okay, now this one's a little bit different because now I have the x in the bottom. In order to get the x out of this and actually find x, it's a little bit weird, but we have to multiply by the x on both sides, which I know to solve for a variable, we hardly ever actually touch that variable. In this case, we actually have to, otherwise there's no way to get to it. Okay, so now that I have that multiplied, the way to get rid of the rest of this, right now I have x times the sine of 35 is equal to 25, is to divide by the entire sine of 35. Okay, so divide by the entire thing. And here x is going to equal 25 divided by the sine of 35. Okay, which again, in our calculator, is fairly easy to do. We're just going to do 25 then we're going to divide it in parentheses by the sine of 35. Okay, go ahead and hit enter. Here we get that x is equal to 43.59 if I go ahead and round that off. So that's going to be my hypotenuse. Okay, and that's really all we're doing for this section. Okay, is kind of these trig ratios and working with these. Okay, so hopefully that kind of helps you out. Make sure you have all of this filled in your notes. You can always go back and look at these again. You should have a homework assignment for today as well. Check your calendar or the backboard in the room, and you should see that homework assignment. Okay, as always, if you have questions or anything else, shoot me an email. Talk to me in class. Make sure you're getting that help that you need. Okay, we'll talk to you later. Bye.